Hi everybody. So in this video, we're going to look at graphing gradient functions. So we've been given the graph of y equals x cubed minus 6x squared plus 9x minus 1. And we're going to graph a gradient function of this. So we'll be looking at how the gradient of a curve changes as the values of x increase. So if we begin at this point, you can see that the y values are increasing. So this means that the gradient dy by dx is greater than 0, because it's an increasing function up to this point. So if I just label the x values on this axis, we can see that the gradient functions will all have positive values of dy by dx, up to the point where x equals 1. Because at x equals 1, we have a stationary point here. This is a maximum. So this means that dy by dx will equal 0. So you can see that when x equals 1, the gradient function will equal 0. And if we continue along the curve until x equals 1 to x equals 3, you can see that the curve is decreasing. So this means dy by dx must be less than 0. We can sketch this from a gradient function because these will all have values below the x-axis. So these are all negative as we travel from 1 to 3. And then as we get to x equals 3, we've got a minimum. So again, this is why dy by dx equals 0. And we're showing that by this route here. And then carrying on along the curve for increasing values of x, you can see this is an increasing function again. So dy by dx will become greater than 0. So our gradient function will be above the x-axis. So this will be our gradient function for this cubic equation. And we can see how this works. If we differentiate y with respect to x, then dy by dx will be 3x squared minus 12x plus 9. And we can check the coordinates of these routes by making this equal to 0. So 0 will be 3x squared minus 12x plus 9. We can factor out this 3, so 0 will be x squared minus 4x plus 3. We can factorize this, and we get x minus 3 and x minus 1. So our roots will be at 3 and positive 1, which they clearly are, here and here. Okay? So I hope that's given you an idea on how to sketch a gradient function. If you did find that helpful, please like and subscribe, and you can download the full lesson and video from my website, mrmathematics.com. I'll leave a link in the description below.